Hello everyone. This is an open source $9 ROM burner, and today we're going to give it a bunch of upgrades. Different kinds even. We're going to physically mod the first division of the board a bit, and we're all super lucky someone wrote some pretty cool code for the Arduino Uno, making it even easier than using MiniPro. It's called Firestarter, and it's made to make it super easy for non-super geeks to get it up and running. More on that a bit later. If we take a look at the first version of the PCB and compare it to the later versions, we'll see that the later ones have a few more resistors in this general area. A lot of people bought the first version, completely overwhelming me over the first weekend, so it didn't take long before those resistors got added. And by now, even more people have bought the later revisions. So to avoid forking the software into two different branches for the same platform, I'm gonna show how to upgrade the original. But first things first. If you haven't heard of this magic $9 ROM burner shield before, it's called the Relatively Universal ROM Programmer. Not the greatest name, to be honest, but it's called that because it's meant to program any old PROM, EEPROM or EEPROM, and it works on either an Arduino Uno or my very own 6502 based 6501. And of course, there's a bunch of other development boards out there which accept the same shield footprint if you have some driver code. And speaking of driver code, the Relatively Universal Programmer platform now has 3 different firmwares. The first is the 6502 assembly code I wrote for the 6501, so it can burn and clone ROMs for itself. The second is the self-contained Arduino sketch I wrote for the Arduino Uno, which aims to make the Programmer Shield into a standalone ROM multi-tool to quickly test, blank check and erase EEPROMs even without a PC around. And then there's the third that I didn't write myself. Meet Firestarter for the Arduino Uno, written by Henrik Olsson. Henrik dropped into my little retro computing hackerspace clubhouse on Discord, asked a few questions, and before anyone knew it, he had working code for the Arduino Uno, a firmware part for the Arduino Uno, and a Python app for the host computer. By the way, come hang out, it's free, and I'd love to see what you're making too. There's an invite link in the description. I like my own firmware for the Uno too, and it's not going anywhere, but I absolutely love the work Henrik put into making Firestarter and how insanely easy it is to get going and immediately turn the $9 shield into something that'll at least partially compete with the ex-Gecko programmers and MiniPro. To make this video, I once again had to ask my friends over at JLC PCB for another sponsorship, and they kindly sent me this. The last time I revised the board, I already added the upgrade we're going to make on the first version today, so let's circle back to that later. But for this one, I decided to up the resistance on the green LEDs to 10K, since they were still super bright at 4700 ohms. I guess it's just a combination of the fact that modern LEDs are really efficient and most human eyes are super sensitive to the color green. So let this be a friendly reminder. If you're using green LEDs from the basic parts catalog at JLC PCB, don't use the myth of the 20 milliamp rule of thumb for an LED. At almost an order of magnitude lower than that, at 0.3 milliamps, I'm sure they'll be plenty bright. Thanks again to JLC PCB. It's really amazing to get the synergy of making cool open source projects like this and share them with others without investing too much of my own money and still getting physical hardware to play with. For this one, I also just install a 32-pin dip socket, but I plug a ZIF socket into it to make it easy to use. That way I can reuse it later and only leave the cheap dip socket in the Programmer Shield. Remember, the cyan-colored ZIF sockets won't fit in a dip socket, but the black ones will, so I only have the black ones on my store. And thankfully, it looks like it works perfectly. Now I could use this new revision for testing the Firestarter firmware, but since it won't work as well with the first version, let's upgrade that one and use that instead, so we don't leave anyone behind. If you have a Rev 1 shield or newer and you don't care about the difference, but just that it works, you can skip this part. The easy way to recognize the first version is that it only has red LEDs and it's missing a few resistors near the calibration potentiometer. The TLDR is there's a voltage divider added so the Uno can read the programming voltage. If you haven't heard of a voltage divider before, it's a trick we can use to read a higher voltage than the pin we're reading it with is rated for. Essentially, we're scaling the 0 to 36 volts the programming voltage can be, down to the 0 to 5 volt range the Arduino Uno analog pin can read without letting out the magic smoke. On the schematic for Rev 1 and forward, you'll see I used a 270k resistor as R1 of the voltage divider to drop down the VPE voltage, and two 22k resistors equaling 44k as R2. That means the output on the Arduino pin A2 is a bit over 6 times lower than the input, which should be safe even if the boost regulator on the shield is set to the absolute max it can handle of 36 volts. So even under the worst conditions, the Uno is safe. Now to do the upgrade under normal conditions, I would solder on 2 SMD resistors and some magnet wire and be done with it. But since that's slightly more finicky and not easy for everyone, I'm going to grab the 2 closest value through-hole resistors I have and cut and bend the leads to fit. I don't have a 270k through-hole resistor or a 44k for that matter, but as you'll see when we get to the software, it doesn't really matter. The only thing that really matters is that the ratio of R1 to R2 is the same or higher, at least a little bit over 6. So since I have a 300k and a 47k, that'll do just fine. Now I'm sorry to say I'm not a master of soldering under a camera, but I'll give it a try. I start with the 300k resistor from VPE to A2 and bend the legs to check it's going to fit, and then I cut it to size at the bends. I solder it to A2 first and then make sure the lead is only touching the solder mask on the way to the resistor pad we use to connect VEP. I really hope it'll end up being clear how to make this modification, even if it's not the greatest camera work in history. After that, the hardest part is over, since the other resistor just has to go from the same analog pin as the first one to ground. So I solder it to A2 first, and then there's a convenient ground on 2 pins next to each other, which means it's easy to solder to either ground pin without the risk of making a short. All that's left is to put the new resistor values in the Arduino sketch I made, and we're done. As you can see, that means the 2 resistors end up on top of each other, which is totally fine, but I wouldn't be surprised a lot of you can do a better job, or can find better placements for the bodge. Please share your upgrades on social media or on Discord, I'd love to see it. With all that out of the way, let's try out the Firestarter firmware. Right now, I just have the Arduino sketch I wrote installed, and for a baseline, before we begin, I do a quick test using the W27C512. The Firestarter app for the host system is written in Python, and the firmware itself is written using the Platform.io IDE, but you don't even need that to install or use it. All you need to program the firmware to the Arduino Uno is Python and AVRDude. AVRDude is used to program the Uno and is included with the Arduino IDE, but also available through most package managers. So for completeness, I install it using macOS Homebrew. Getting the Firestarter app is as simple as pip install Firestarter. From there, you could probably imagine you'd have to install the Platform.io IDE or install a hex file with AVRDude, but Henrik had the foresight to simply include that part with the app. So with the command Firestarter FW -- install, we have a working programmer and we can check current firmware by running Firestarter FW. Firestarter doesn't use the SSD1306 display at all, so the screen just shows the last screen of the previous firmware. If we unplugged it and plugged it back in, the screen would just stay blank. Now we know this programmer already has the correct programming voltage for this chip, so we don't need to calibrate it, but if we want Firestarter to report back the actual programming voltage, we need to tell it what resistors we just installed for the voltage divider. Unless we installed 270k and 44k like the default ones, of course. So I set R1 to 300,000 and R2 to 47,000 ohms. If you know your Arduino VCC is a little higher or lower than 5 volts, you probably also want to set that. And with those 3 commands, we installed the alternative programmer app, the alternative firmware. We can read the programmer voltage, and we're ready to program ROMs. Super easy, so thanks to Henrik for making it that way. Now, as far as I can see, Firestarter already has a large database of ROMs and does basically all the same things MiniPro does, limited by the Relatively Universal ROM Programmer's capabilities, of course. But let's start simple with a blank check. Pretty simple syntax, Firestarter blank W27C512, and yes, it reports as blank. Good start. Let's go right ahead and burn a 65 Arduino ROM to try it out, and if I remember to specify the chip, it might actually work. And it looks like it did something. Henrik told me it checks each byte as it's written, so it's basically already checked, but let's try to read back the whole ROM and compare to the file we wrote. And if we check the top of that file, it certainly looks right. And if we run a diff, we see it starts differing after the file ends, simply because the ROM is larger than the file we wrote. Perfect. Other than that, we can read VPP, of course, and use that to calibrate it for a ROM with a different programming voltage. Now finally, let's see if we can also erase it. That does seem to take 3 tries, and I suspect that's due to the pre-charge period in the firmware being a bit low, and I've already let Henrik know about it, so expect it to be fixed in firmware 104. One of the benefits to adding the voltage divider is we can add over or under voltage check in software, so we lower the risk of frying chips with a higher voltage than they can handle. That feature isn't quite there yet, but I've been told it's coming soon. I've also been chatting a bit with Henrik about adding transistors instead of the current manual jumpers to make the ROM pin count selectable in software. And I think that's a very good idea for a future hardware revision. And I think it'll even be backwards compatible. Like I said, I like my own firmware too, but this really is the easiest way to get going if you just want to program a few ROMs for your Commodore 64 like Henrik initially set out to do. I am so happy he was inspired to give it a bit more than the basics and even share his efforts, because this is pretty cool. Henrik also made his own video about Firestarter, so I've linked that in the description. If you would like to buy a $9 Programmer Shield too, there's also links for that, as well as the complete source. So you can also modify and make your own. Feel free to come hang out on the free Discord server and ask anything you like. Either way, thanks for watching.